Hello, and welcome to this series of videos on the TI-30XS calculator. My name is Becky McGuffin, and I'm a math instructor with the Heartland Adult Education Consortium. The goal of this series of videos is to teach you how to get the maximum benefit out of your calculator on test day. When I tutor students, I always begin by asking them how comfortable they are with the calculator. And they almost always reply, "Oh yes, Miss Becky, I know how to use the calculator." But as I work with them, I find they really only knew how to add, subtract, multiply, and divide. I often hear, "I didn't know the calculator would do that," after I show them one of the calculator functions. In this series, we'll go over exponent buttons, scientific notation, fractions, percents, even the store and variable buttons that you'll be able to use for more challenging algebra problems like those you'll find on the GED. If possible, I suggest you have one of the calculators in your hand as we go through these videos. That will allow you to practice each of the keystrokes as we go through different examples. This journey may be long, but I promise it will be rewarding and you will learn something about your calculator before we finish. So let's begin. The next buttons we're going to go over are the store and variable button. And we're going to do so many different things with these two buttons that it's going to take 2 or 3 videos for me to cover everything that these buttons will allow us to do. But find the store button in the lower left. It is STO with a little arrow. And then just above it is the variable button, X, Y, Z, T, A, B, C. The calculator will store up to 7 variables at a time, but the most we'll need for the GED is probably 2 or 3. To store a number for a variable, remember the sequence number, store, letter, enter. Number, store, letter, enter. For example, if we want to store the number 3 for X, we will type 3 store X, enter. And the calculator shows me in the screen that we have stored 3 for X. We can now type in whatever problem we want to do with X as 3, and the calculator will do the math for us. If we want to see what number is stored for X, we can hit our second, and store shows me a recall to show me that 3 is stored for X, 0 is stored for Y, 0 is stored for Z. I can scroll down and see the other numbers have 0 as well because I haven't stored anything for any of those letters. So the calculator 3 will remain stored in the calculator until I store something else on top of it. So if I have 3 stored for X, now if I wanted to do any problem with 3 as X, 6X plus 4, when I hit enter, the calculator takes the 3, substitutes it in for the X, 3 times X is 18, and then adds 4 to give me the answer 22. I think the best way for us to go through to learn this skill is to practice it with several examples. So first, let's look at 3x plus 2 equals 5. This is just a simple problem, and we probably wouldn't even need to use our store button to find the answer, but to practice learning how to store, it's a good one to begin with. If I take the 5 and put it in for the X, 3 times 5 is 15, plus 2 is 17. But we're going to store 5 for X. Remember, number, store, letter, enter. 5, store, X, enter. And the calculator shows that I have 5 stored for X. Now we're going to type in our problem, 3x plus 2. And the calculator is going to substitute 5 in for the X, do 3 times 5 plus 2, and tell me the answer is 17. And as I mentioned, this problem is easy enough you might not need the calculator to do this. But I can use this same store button with the variable for more complicated problems, like this one. And the reason I think this problem is more complicated is for 2 reasons. One, I have a negative value 2, I have an m instead of an x. And 3, I have exponents that we have to remember what the exponents actually mean to do. So we have multiple reasons why this problem is a little bit trickier than the last problem we did. So first thing, my calculator has X, Y, Z, T, A, B, and C. I don't have an M. Is that really a problem? No, it's not. It doesn't matter what letter I use. I can use X's for all of these M's. As long as I store -2 for X and type in X's in place of those M's. So we're going to store -2 for X. -2, store, X, enter. The calculator shows me that -2 is stored for X. Now I'm going to type in this problem we have. 3, I don't have M, so we're going to use X. We put our exponent of 2 minus 2x plus 12. And the calculator is going to square -2. -2 times -2 is 4. 4 times 3 is 12. Minus 2 times -2 is another plus 4. 12 plus 4 is 16, plus another 12 should give me 28. And there is our answer, 28. But the calculator will do all of that without you having to figure out what it is. Okay, and one more example that even is more tricky, looks even more hideous when we first look at it, is something like this. But no need to panic, because as long as I know the value of the variable, I can store that number for X. So we have 2, X is equal to 2. So we're going to store 2 for X. I'm going to clear my calculator, and we're going to store 2 for X. Number, store, letter, enter. 2, store, X, enter. Now the screen shows me the calculator has 2 stored for X. I want to type in this problem, but let's recall from some past lessons that I have a fraction line. So I don't have to enter this as 2 different problems. I can hit my fraction line and type this whole thing on the top in the numerator, and this in the bottom is the denominator. So I want 5x cubed, 5x. To get the exponent of 3, we have to use our caret button and put the 3. We're going to scoot over, minus 2x. The x squared button will put my exponent of 2, plus 10. Now we're going to go to the denominator and type 3x plus 1. And I always take a second to check and make sure what I have typed in the screen is exactly the problem that I have been given. And when we hit enter, we get the answer is 6. Who would have thought that a problem so complicated as this would give us the simple answer of 6? As I mentioned earlier, the calculator will store up to 7 variables. Let's explore how to store more than one variable. Remember the sequence: number, store, letter, enter. We're going to follow this sequence for every variable that we need to store. So let's do these 3 variables. We're going to store 3 for X, 2 for Y, and 5 for Z. And then we're just going to add those 3 together. So I'm going to store 3 for X. Number, store, letter, enter. 3, store, X, enter. Now I want to store 2 for Y. Number, store, letter, enter. 2, store. When I hit my variable button one time, it brings up an X. If I hit it a second time, it changes to a Y. And hit enter. And 5 for Z. Number, store, letter, 5, store. Once for X, twice for Y, 3 times for Z, and hit enter. And the calculator, I can see in the screen that I have 3 stored for X, 2 stored for y, and 5 stored for z. If you want to check and make sure that those are correct, you can hit your second and recall button to see I have 3 stored for x, 2 stored for y, and 5 stored for z. Now we're going to just type in the problem x plus y plus z, x plus once for x, twice for y, plus once for x, twice for y, 3 for z, and we get the answer of 10 because 3 plus 2 plus 5 is 10. Just like when we were doing one variable, I think the best way for you to learn this skill is just to practice and look at different examples. So let's begin by doing 3x squared minus 2y cubed. First thing, I'm going to clear my calculator. I don't have to clear the memory because as soon as I store -1 on top of x, that previous x value is going to be gone. So you don't have to clear the memory. The calculator will stay, the number you have stored in the calculator will stay there until you store something else on top of it. So when I store -1 for x, that last value of 3 is no longer going to be there. So -1 store x, enter. And 2 for y. Number, store, letter, enter. 2 store 1 for x, 2 for y. And now I can see that I have -1 stored for x and 2 stored for y. We're going to type in the problem 3x squared. Now one mistake I see students make is they'll just do 3 and then they'll hit this x squared button. You have to put the variable x there before you put the x squared to put the exponent. So 3, my variable x, and then my exponent of 2, minus 2y, once for x, twice for y, and then the exponent of 3. We'll use our caret button to put the exponent of 3. We'll move over before we hit enter, and we hit enter, and we get the answer is -13. Another example using x and y. This one has a little trick we have to learn where we have the x followed by the y. So we have an x is -2 and a y is 4. So the first thing we have to do is store those values for the variable. The store button can save you so much time as long as you know the value of the variable, store that value, and then just type in the expression. So we're going to do -2 for x. -2 store x, enter. Number, store, letter, enter. And now we're going to store 4 for y. 4 store, once for x, twice for y, enter. Now the calculator shows me I have -2 stored for x and 4 stored for y. So now we can type in the problem we were given. 2x squared. 2, we have to put the x variable there, followed by the x squared to put the exponent of 2, plus 2, now here's where it gets tricky, xy. I'm going to put the x there. And now if I want to put the y there, if I hit it again, it just changes that x to a y and keeps changing. You know, I can't get the x next to the y. Here's the trick. When the x is there, you have to move your cursor over. You can't see that your cursor's moving over, but by pushing the cursor over, now I can add the exponent of y. Minus 3x squared. And when I hit enter, I get the answer of -20. So this trick right here is one that when you practice it a little bit, you'll remember, but the first few times you do it, when you have to type a variable and followed by another variable with no symbols in between, sometimes it takes a minute or two to recall how to do that. So once again, practice, 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 and you'll get to where you just remember how to do it. Okay. Let's look at one other example with storing multiple variables. And this one, I have, instead of an X and a Y, I have an R and an S. Oh no, my calculator doesn't have R and S. It just has X, Y, Z, T, A, B, and C. Is that a problem? It's not, because just as we did with one variable, I don't have to use R and S. I can use X and Y. As long as whatever I change these variables to down here, I change them in the problem when I'm typing it in my calculator. So if we're going to store 2 for X instead of R, all these R's up here, we need to use X's. And if I'm going to store -1 for Y instead of S, anywhere there's an S, we want to put a Y. So now we'll clear our calculator. The first thing we have to do is store the variables. So we want 2 stored for X. Number, store, letter, enter. 2, store, X, enter. And I want -1 for Y. -1, store, once for X, twice for Y, enter. Now that I have my numbers stored for my variables, we can type in our problem. It's one of those more complicated ones where I have a fraction line. So we'll hit our fraction, and we're going to type 2x squared on top. 2, the variable x, and then the exponent of 2, plus 5xy. 5x. Before I can put the y, I have to use my cursor to scoot over, and then I will be able to put the y next to the x. Plus y squared. Once for x, twice for y, and the exponent of 2. We'll scroll down, and on the bottom, we just have x plus y. Once for x, twice for y. I like to always take a minute, check and make sure what I have typed in my screen is exactly the problem that I was given. We're going to move over before we hit enter, come out from the fraction, and when we hit enter, we get the answer is -1. It doesn't matter how complicated the problem looks. If you know the value of the variable, you can store those values for the variables, type in the problem, even if it is crazy complicated, and the calculator will do all the math. It won't make any mistakes with your integers as long as you've typed it in correctly. It won't make any mistakes with exponents. It won't make any mistakes with simplifying the fractions as long as you enter the problem correctly. It's a great tool to make sure that you get problems like this correct on the GED. Another way we can use the store button to evaluate expressions is when we're trying to evaluate functions. And sometimes functions confuse students because they may not understand what function notation looks like, or the question just looks a little different than they're used to seeing. So let's look at what these questions look like and figure out how we can use the store button to work through them. So this first question is just evaluate the function. F of x equals 2x cubed minus 3x plus 4 for f of -2. And so with function notations, what they want you to do is take this number that's in our parentheses and put it in for the x. So if you have function notation, this is just going in for the x. So we're going to use our store button, and we're going to store -2 for x. So on our calculator, number, store, letter, -2, store, x, enter. And now the calculator has -2 stored for x. Now all we have to do is type in this equation or this expression that they give us for the function. 2x, notice I have a cubed here. For any exponent other than 2, we're going to use our caret button and put our 3. Our cursor's flashing up here beside the exponent, so we need to move over to bring it back down to the main level. Minus 3x plus 4. And when we hit enter, we get the answer is -6. That is the value of the function when -2 is put in the function for these x's. If you see f of x and f of 5, whatever numbers in the parentheses is what you're going to store for the x. The other way that function questions are presented is in word problems. Students hate word problems. I get it. They cause you anxiety. You have to do some reasoning skills to figure out exactly what they're asking, and sometimes that can be very challenging. So let's look at a few questions with word problems that are evaluating functions. So this first one, the equation h equals -16t squared minus 48t plus 500 represents the height of a ball t seconds after being dropped. What would the height of the ball be 3 seconds after being dropped? So we have this equation and we're trying to find out the height of a ball 3 seconds after being dropped. So how can we do that? Well, let's look a little closer at the equation they give us. -16t squared minus 48t plus 500. What does t stand for? Well, t stands for time. Time, t seconds. This t is time in a number of seconds. And what does the question want us to know? 3 seconds. So if I have t seconds and I want to know 3 seconds, we're going to take the 3 and put it in for the variable t. Do I have to use the variable t? No, we can use x. We could use t, but it would just require more punches of my variable button to get to the t when we have x, y, z, t, a, b, c. We just have to punch it more times. So we'll just use x. 3 store x. 3 store x, enter. We've entered the time of 3 seconds. And now we're going to put in this equation, -16 x squared. Put our variable x there, and the x squared button puts the exponent. Minus 48x plus 500. And when we hit enter, we find out the height would be 212, probably feet high after being dropped 3 seconds in its flight. If I put 2 seconds, 1 second, we're going to get a different answer. But the question wants to know 3 seconds. So 3 seconds is what we put in for the x or the t. In these types of questions, most of the time, if they give you a function and they want you to find an answer, they'll give you what number goes in for the variable. We just have to look for it closely. So let's look at another example. The function f of x equals 0.75 7500ths times the quantity 3x squared minus x minus 16 models the cost to weave a square tapestry with a side length of x feet. What does my x stand for? Feet. It's how long the side is in feet. Use the function to find the cost of weaving a tapestry with a side length of 9 feet. So I'm looking for the cost of a tapestry. It's square and each side is 9 feet. X feet, 9 feet. We're going to put 9 in for x because that's the cost we're looking for. So we're going to store 9 for x. 9 store x, enter. And now we can type in this function, 0.75 parentheses, 3, put our x there, our exponent of 2, minus x minus 16. Close my parentheses. We're going to take a second to make sure that what I have typed in the screen matches the problem we're given. And when we hit enter, we get the cost of $163.50. If I wanted 8 feet, the cost is probably going to be a little less. If I want 10 feet, the cost is probably a little bit more. But for 9 feet, when x feet, and that's the function, put 9 in for x, and it gives you that cost for 9 feet. Most of the time, if they are asking you to evaluate a function with these word problems, they're going to give you the number that goes in for the variable. There's a few examples when they don't, and let's look at one of those. So Jill purchased a new vehicle valued for $42,000 in 2016. The value of the vehicle depreciates $1,400 each year. The function 42,000 minus 14t can be used to determine the value of the vehicle after t years. What was the vehicle's value in 2023? Okay, so let's look at this and see what they tell us. They tell us when I purchased a new car, its value was $42,000. And that was in 2016. The word depreciate, vehicle's value goes down each year. As a car ages, the value decreases $1,400 each year. So I could say, okay, if it was $4,200 in the first year, I could subtract $1,400 each year to get to that final cost. But here's the other thing we can do. T years. How many years am I trying to find? Well, they didn't really tell me that. But I bought it in 2016 and I want to know the value in 2023. How many years is that? If I take 2023 and subtract 2016, that tells me this is 7 years of owning the car and 7 years of the car depreciating. So 7 is how many years we're looking for. I want to know, I know the value in 2016 was 42,000. I want to know the value in 2023. That's 7 years later. So we can store 7 for t or for x, type in our expression, and it's going to give me the value 7 store x, 42,000 minus 1,400x, subtracting $1,400 each year. And we get the value of 32,200 for the value of the vehicle 7 years later. Now, as I mentioned, I could do this a little differently. If you have trouble figuring that out, I could say, okay, in 2016, it was 42,000. So in 2017, it's going to go down 1,400. I'm going to subtract 1,400. 42,000 minus 1,400 gives me 40,600. 2018, we're going to subtract another 1,400 and we get 39,200. 2019, subtract another $1,400, 37,800. 2020, subtract another 1,400, 36,400. We're getting closer. 2021, 1,400. 36,260, 2021, 22 minus 1,400. Oh, oops, I messed up there, didn't I? I only subtracted $140 instead of $1,400. I missed a zero. So let's go back here. That was this one. Let's go back to 37,800. 37800. Minus 1,400. So this is 36,400. That number was right. Minus 1,400 gives me 35,000. Minus another 1,400 for the year 2022, 33,600. And 2023 minus another 1,400 gives me 32,200. Oh, there's our answer. So we just confirmed that it's right. It took us a little longer, but we got there. So even with me making a mistake and finding my error, we were able to get to the same answer either by listing all these years and subtracting $1,400 each year, or if I know this is 7 years' time, we can put 7 in for the t and just solve the function using the store button to find out the value of the vehicle 7 years after it was purchased. Now it's time to practice. I encourage you to get to know your calculator, get very comfortable with it, and learn as many tips and tricks as you can for your calculator to help you on test day.